All right, these are the answers to the Calculus BC free response from 2015. So they give us a Maclaurin series here for some function f, and they want us to find the radius of convergence. So we don't need the full-on interval. We don't have to worry about endpoints. We just have to figure out what that radius is. That makes this a little bit easier. So the ratio test says take the limit as n approaches infinity of the next term, that'd be -3 to the n, x to the n plus 1 over n plus 1 divided by -3 to the n minus 1, x to the n over n. And we want that to be less than 1, okay? So if you flip and simplify, what you're gonna have is an n over n plus 1. That will flip up, that'll be over there. You'll have x to the n plus 1 over x to the n, so that's an x. And then you'll have 3 to the n over 3 to the n minus 1, that's a 3, or a -3 then. Okay. So this is what we're gonna end up with right here, right? And the limit as this goes to infinity ends up being 1, so really it's the absolute value, and because it's absolute value, that doesn't matter so much. We end up with the absolute value of 3x less than 1. So if I were to write it like this and divide, I get x between -1/3 and 1/3. Now, again, the whole idea here is we're trying to find the radius of convergence. So we know this is centered at 0. It goes from 0 out to 1/3. So I don't have to worry about the endpoints or anything. My radius of convergence for this is 1/3. That's all they were looking for. So they would want to see the setup, the simplifying, and then the final conclusion. Right? That's what they were looking for here. For part B, it says, can you write the first 4 non-zero terms for the Maclaurin series of f prime, the derivative, and express it as a rational function? So again, what I would do is I'd go back to f. They started that out for us. They had it as x minus 3/2 x squared plus 3x to the third. And then if we kind of keep going with this, I would go ahead and put 4 in, and you'll get -3 to the third power, so that'll be a -27 times x to the fourth, and that would be over 4. Right, so these are your first 4 terms of f. And what they want us to do then is to figure out, well, what's f prime? So f prime then would be just the derivative of these. So it would be 1 minus 3x plus 9x squared minus 27x to the third, okay? So again, I took the first 3 they gave me, I figured out what the 4th term would be, and then I just took the derivative of each of them, okay? Now, when they say, write it as a rational function, what they mean is, do you notice that there's a common ratio here, all right? Like if you look, how do I get from term to term to term to term? Well, to get from 1 to -3x, I multiply by -3x. To get from here to here, I multiply by 3x. To get from here to here, I multiply, by -3x. To get from each term to the next term, I just multiply by -3x. That's our common ratio then. So that means that using an infinite geometric sum, this function would equal its first term over 1 minus the common ratio. It should be 1 over 1 plus 3x. That's actually what f prime is equal to. It's crazy, but that's how we can do it, because we see a pattern there in how to get from term to term. All right. Then this one says, write the first 4 non-zeros of e to the x. So we know e to the x is 1 plus x squared over 2 factorial plus x to the third over 3 factorial. There's your first 4 non-zeros. Use the Maclaurin series for e to the x to write the third degree Taylor polynomial for g of x, which is e to the x times f of x. Now, I'm taking this now, and we're going to multiply it by f of x. And f of x was given to us from previously as x minus 3/2 x squared plus 3x to the third, and then some other stuff. Now, they only want the third degree Taylor, so we don't want to go past the power of 3, all right? So that, in other words, we're just going to multiply and see what happens. This g of x, I should say g of x here. This is e to the x here. This is f of x here. Okay, so g of x is equal to all of this multiplied down. G of x is going to be 1 times x, 1 times this, negative 3/2 x squared, 1 times that, which is 3x to the third, then x times that, which is x squared, x times that's negative 3/2 x to the third. I don't have to worry about the next one. Don't worry about that. X squared times this would be x to the third over 2. X squared times x squared would give me something to the 4th power. I don't want that. And I don't want this either. That'd be to the 4th. I only want things up to the 3rd power. So I'm going to have g of x is going to be approximately x. Negative 3/2 plus 1 is a negative 1/2 x squared. And then 3 minus 3/2 plus 1/2 would be 3 minus 1, which is 2x to the third. There's our third degree polynomial for g of x.